Okay, section 8.1 is the Pythagorean theorem and its converse. You should be familiar with this. We're going to do a couple new things with it. So the Pythagorean theorem, if a triangle is a right triangle, then the sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. In a right triangle, we're always going to use C for the right angle. Therefore, capital C is the right angle, small c is the hypotenuse. Capital A is another angle. The side opposite it is small little a, and capital B and lowercase b for the opposite angles and sides. So what we're saying here is that the two legs, A and B, if I take a squared plus b squared, it will always equal c squared if I have a right triangle. So for example, let's look at this triangle. And I'm going to say that this side is 6, 8, and 10. So my legs, 6 squared plus 8 squared, should equal 10 squared. 36 plus 64 equals 100, and this is true, so this is a right triangle. Pythagorean triples are a set of non-zero whole numbers that satisfy the Pythagorean theorem. We just did one, 6, 8, and 10. It's more commonly known as the 3, 4, 5 right triangle. Any sides that are in the ratio of 3 to 4 to 5 will always be a right triangle. This is one that I want you to remember and memorize, that any triangle with the side lengths 3, 4, 5, or any proportionate triangle to that will be a right triangle. Some of the other common Pythagorean triples are 5, 12, and 13, 8, 15, and 17, 7, 24, and 25. If you become familiar with these, you can save yourself a step or two when you're doing the problems. Everybody should be familiar with the 3, 4, 5 right triangle. Okay, Theorem 8.2, the converse. If the sum of the squares of the lengths of two sides of a triangle is equal to the square of the length of the third side, then the triangle is a right triangle. So all we're saying here is that in Theorem 8.1 was if it is a right triangle, then the squares of the legs add up to the square of the hypotenuse. Now we're saying if you have a triangle and the square of the legs, the sum of the square of the legs equals the square of the hypotenuse, then we know it is a right triangle. So you would be asked to do something like, is this a right triangle? So if I have three sides of 13, 85, and 84, I want to know if that's a right triangle. These are my side lengths. So first I've got to pick out the hypotenuse, the longest side. So 13 squared plus 84 squared equals 85 squared. If you use your calculator, obviously, this is going to be 7225, and that also equals 85 squared. So yes, it is a right triangle. Now we're going to look at some other things when it doesn't equal exactly the squares. What else can we tell? So Theorem 8.3 says if the square of the length of the longest side of a triangle, again, we're not calling that the hypotenuse because we don't know if this is a right triangle or not. So if the square of the length of the longest side is greater than, not equal to anymore, but greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. So if I have a triangle with side lengths 6, 11, and 14, I'm going to take the longest side, and I'm going to say 6 squared plus 11 squared, and I don't know yet whether it's going to be equal to, greater than, or less than, so I'm going to leave the symbol blank and put 14 squared on the right. So 36 plus, oh, I'm sorry, I did this wrong. 36 plus 11 squared is 121, and 14 squared is 196. So I've got 7, 5, 157, and 196. And in this case, it's true. the square of the length of the longest side is greater than the sum, so this is an obtuse triangle. I hope we remember that obtuse means that it has an angle greater than 90 degrees. So this angle measure is greater than 90 degrees, and that's because this side is so much longer than the other two. The last one says that if the square of the length of the longest side of a triangle is less than the sum, then the triangle is acute. All of its angles are less than 90 degrees. So we have three situations. If a squared plus b squared equals c squared, we have a right triangle. If a squared plus b squared, losing my pen again, is greater than c squared, we have an acute triangle. And if a squared plus b squared is greater, wait, I said that already, is less than c squared, then we have an obtuse triangle. Okay, where c is the longest side of the triangle. And that's all we have for today, so I'll see you in class.